And what would be the error there?
No, unfortunately, it's very challenging. Of course, the Western Cape is relatively good, but in many of the other provinces, there's partial data, and there's also delays, of course. You saw, I think, yesterday or the day before, they announced more than 500 new deaths. Clearly, that was historical kind of past deaths. So in fact, when you do these models, you ideally want to know exactly how many people are in the different states at each time. And so when they amalgamate them and delays, then it will mislead the algorithms a bit, the models.
And I have one more question about the modeling part, which is that, I mean, in India, for example, we have this major problem that all the modeling and all these models suggest that we should stay inside and there should be social distancing and so on, and that's how we stop the spread. But we know that there are people who just that the living conditions are such that social distancing is not possible. So how does one factor that into modeling and forecast? Is there a way to do that? Because I mean, it's very important, right?
Yes, absolutely. I mean, it's also for South Africa, it's a critical factor. Yes, the models, typically the way you would do it is you would treat each age group separately, and then you would say, how much do the different age groups interact? So there would be a contact matrix, and then you would say, well, for each group, how many people do they on average chat to? And you would split it up by work, by home, and you could also split it up by essentially section of the population. So poorer people tend to struggle to socially distance, and so you can model that when you go into lockdown, will it have any impact? The great problem is you end up with hundreds of free parameters that you don't know what they are, right? Like, how much will lockdown affect the average person? Well, you can kind of take a guess, but you don't know for sure. And that just introduces a lot of uncertainty, even more uncertainty into the models. So it's extremely challenging because we all want to know the answer, right? So it's all very well to say, well, somewhere between 5,000 and 500,000 people will die in South Africa. That doesn't, in a sense, doesn't actually help politicians in making the decision. So then it becomes a social question of how much risk are you willing to take? And of course, there are consequences, right? Because as some of the speakers referenced, if people are not working, then you don't want lots of people dying of starvation as well. So it's exceptionally complex. Yeah.
Right. Yeah. Thanks.
Pleasure.
Could I ask a question to Bruce as well?
Absolutely. Go ahead.
So Bruce, what I find interesting is that, we watch on TV that the government makes certain pronouncements based on data. We don't know who these people are that are putting these models together, but what happens when the data is wrong? Are there certain ethical ramifications? Because, if we say that the virus is spreading rapidly, you all need to stay home and stay unemployed, that has other implications. If you say that the statistics show that alcohol is very dangerous in our situation, and so are cigarettes, and it's proven to be wrong, based on certain models, are there certain ethical or legal implications?
So that's a great question, and I'm not the right person, since I'm, the legal aspect is probably quite subtle. The ethical one is, we can all have an opinion about. I would say, if I tell you, definitely 1 million people are going to die, I promise you my model is never wrong, and then that turns out to be wrong, then I think you can legitimately come back to me and criticize. And I think this is a valid criticism of a lot of the models, both of the national model and of the people claiming that there will be very few deaths, is that, in my view, they underestimate the uncertainty to a large extent. The truth is, I honestly believe that nobody can predict to within a factor of perhaps 3. So for example, somewhere maybe between 30, my best guess would be we're probably going to look at between 30 and 90,000 deaths for South Africa. But if it doesn't turn out to be that, that could definitely be wrong. But anyone who tells you we know for sure that it'll be between 20 and 25,000, I think that's completely wrong. Now, I could be wrong too. That's the thing about science. We must admit that we just don't know. So I think if allowing for the fact that these models are highly uncertain, then you can make a decision. So another way to phrase this is you could say, well, what's the probability that we'll have more than 100,000 deaths? And I would say it's probably 20%, 25%. So given that perhaps there's 25% chance that we'll have more than 100,000 deaths, now you can ask, what should the government do? And you can have a debate about, do we go into lockdown with a guaranteed cost to the economy for a 25% chance of more than 100,000 deaths? So that's the way I would phrase it, is in terms of risks, and are you willing to take that risk? If I put a gun to your head and said there's a 1 in 4 chance that there's a bullet is going to go off, what would you do? Would you take that risk if in return you were guaranteed to get 50,000 Rand if you pulled the trigger? That's a kind of a personal decision. And of course, what it makes it hard is it almost opens it up to the public to give their opinion, and people will have opinions about it. So it then goes into the question of what is the right way for governments to communicate with societies in a situation like this, and how is the best way to communicate uncertainty and risk? To be fair, the government's initial policy was based on, a lot of it was based on the initial models, which in those times suggested that we might have 300,000 deaths. Fortunately, we know that those models were overly pessimistic, but that's just because we got more information later. Of course, governments tend to struggle to adapt quickly. So I think, yeah, sorry, Steve, I have kind of rambled a bit. But,
no, I get what you're saying. But the one key thing is that you said that, if I had to choose between, 50,000 Rand and a 1 in 4 opportunity of being shot with a bullet, the thing is, I'm not making that choice. Someone's making it for me. And I think that's where the problem comes in. When the government is making a choice on my behalf, that is where debate will always come in. And I think that as people who are working in the maths field, it is so important for us to communicate the numbers and the statistics in an appropriate way. The problem is that where do we source content that is based on integrity? And that's always the hard part as well.
It is, absolutely. I would just say that, you mentioned about these anonymous modelers. I've had quite a lot of interactions with them. They are absolutely exhausted. It's very hard to understand the amount of pressure and the complexity of the modeling. And if I say, if you start to model it, there's many parameters that you have to put in. And depending on what you put in, you get completely different results. And so there's this huge ethical and moral pressure to get the answer right. But of course, nobody sees that pressure, that these people are often on the edge of a nervous breakdown, trying to get these things done and get them right.
Sure. Well, thank you. That was very helpful.